All right, so on example 1, we have a figure and it has that the radius is 4 and that we have an equilateral triangle. The triangle PQO creates an equilateral triangle. And so we want to know which of the following is the coordinates of Q. And so what do you guys know about the angles of an equilateral triangle? They are equal. And what are they in degrees? 60 degrees. Do you guys know what 60 degrees is in radians by chance? It's pi over 3. So 60 degrees and pi over 3 are the exact same angle, just a different measurement. Like 12 inches is 1 foot. So it's the exact same length, just a different unit of measure. So it's the same thing. So what that means is that this angle, all these angles, are pi over 3. If you were going to guess by looking at the special angles, would you guess that this one is pi over 3? Because it's closer to the y. I would too. Yes, it just divides half a circle by 3. Exactly. We could also geometrically prove it by making another equilateral triangle where all of those sides are 4. And so all of those angles are pi over 3. All right, so what I know is the angle that gets you to P is the angle pi over 3. What about the angle that gets you to Q? 2 pi over 3. If you add those 2 pi over 3s, you get 2 pi over 3. Now, you don't have to go through this process every time. What I would do is think about what it looks like. Like, you know, the 3 special angles are pi over 6, pi over 4, and pi over 3. Look at which one it looks like. Look at your answer choices. I think you should be able to figure it out without doing a whole bunch of equilateral triangles. Okay, and so we're going to use this rule, these 2 rules we found, where the x coordinate is r times the cosine of theta, and y is r times the sine of theta. We're looking at point Q. R is 4. Theta to get to point Q is 2 pi over 3. So what choice do you guys think it's going to be? Which one has those? APPC. Very good. All right. Let's look at another one. This one's a little different. So on example 2, this figure shows a circle with a radius r, so we don't know what the radius is. We know that the line y equals negative x intersects the circle at the origin, at P and at R. And we know the coordinates of P are 6 square root of 2 and negative 6 square root of 2. And so what we want to find is the radius. We want to find R. So if we want to find R and we know the ordered pair, we know the x and the y, we can just do the Pythagorean theorem. X squared plus y squared equals r squared. All right, so what we're going to do is just put 6 square root of 2 in for x, negative 6 square root of 2 in for y. And this would probably, I'm guessing, be one of the ones they would want you to do without a calculator. And you don't need one to do this. So when I square 6 square root of 2, you actually square 6. You get 36. What do you get when you square the square root of 2? You get 2. All right, and then same thing, we're going to square negative 6, which is still 36. Square the square root of 2. All right, you're going to need to either know what 36 times 2 is out of your head or go over to the side and multiply it. But what is 36 times 2? 72. And then when we add that, we get 144. So what's our radius? Which is? Yes. You are also going to need to know the square root of 144. Don't think that's something you can figure out. It's just one that you need to know. Your answer choices would also help you too. All right, y'all good? Now, technically, if this wasn't associated with a radius, r would be positive or negative 12. But because a radius can't be negative, it's going to be positive. Okay, so we talked about the unit circle on Friday, and that if we are on a unit circle, which is a circle that the radius is 1, then if I want to find the sine of an angle, all I have to do is use the x-coordinate. And if I want to find the cosine of an angle, all I have to do is use the y-coordinate. And I know this is a unit circle because each one of these points is 1 unit away from the center. So what angle is here where it's just straight to the right? There's 2 actually. There's no rotation, what would it be? 0. And a full rotation, 2 pi. All right, so you guys go around on the x-axis and the y-axis and label those angles. Please try to remember what they are. Okay, so there's, on this concept, there's 2 things you're going to need to remember. One is going to be where the angles are, and you're also going to need to remember or know those ordered pairs. So this one is 1 unit to the right, 1 unit up, 1 unit left, 1 unit down to get those ordered pairs. Okay, and then you're going to need to remember that anytime you want to find a sine on the unit circle, we're just going to use the x-coordinate. And anytime we want to find the cosine, we're just going to use the y. So what would the cosine of 0 be? If I go to where the angle is 0, the cos. Oh my goodness. Forget everything I said. That was all wrong. Fix it. The sine is the y, the cosine is the x. Just like we talked about earlier. Cosine is x over r. Okay. So when I want to find the cosine of 0, I go to where 0 is. I go to the ordered pair and I just use the x-coordinate. If I want to find the sine of 0, I go to 0, go to the ordered pair, and I just use the y-coordinate. All right, so you guys try those other 6 for me. I know your copy on G&H might not be the best. Okay, so cosine is the x, sine is the y. Okay, so let's do some more angles. So the quadrant angles aren't too terrible. Those points are they're the easiest ones to find on the unit circle. But we have the other special angles that are also going to be on the unit circle. And so we're just going to go through like mathematically how it all works out. So we have another equilateral triangle here where all of these sides are equal to 1. So that's why they did 2 1/2. And so for point P, I know that to get from the origin to point P, I go up 1/2. So I already know that the y-coordinate is going to be 1/2. All right, and then when they've already gone through this, to find the x-coordinate at that point, what they did is they did the Pythagorean theorem again. This time, x is what we're looking for. They put in the 1/2 for y and put in 1 for the radius, squared all the things, subtracted, and took the square root, and found that x is either going to be positive square root of 3 over 2 or negative square root of 3 over 2. What do you guys think is going to be for p? Positive or negative x value? Positive. In quadrant 1, all the stuff is positive. All right, now if we had a point over here in quadrant 2, then the x would be negative. Quadrant 3, the x and y would be negative. All right, so let's see. All right, just some important notes is that, like I was saying, we found two values for x, and it really just matters what quadrant we're in if we choose to do the positive or the negative. And then the Pythagorean theorem will come in to play more times in the student. Okay, so here we go. So this is the point we just found. The theta was pi over 6, and we found the ordered pair, square root of 3 over 2 and 1 over 2. All right, so Q is reflected across the y-axis. So what is theta? What's the angle at Q? And this little part is at Q? Q is going to be 5 over 6. Good. All right, and then the ordered pair should be corresponding points, but because we're in quadrant 2, the x is negative and the y is positive. All right, so you guys go ahead and do that. Same thing for R and S, please. All right, so the angles are what we kind of worked on Friday, and then today we're going to do angles, and we're going to do the order pairs. All right, so let's look at the next table. So the next table, we're dealing with pi over 4 as our special angle, and you can look at the math that they figured out, but the ordered pair there is going to be square root of 2 over 2 and square root of 2 over 2. So Q is in quadrant 2, so what would pi over 4 be in quadrant 2? Don't remember? 3 pi over 4. So when you're doing the pi over 4 angles in the other quadrants, you're just going to go to the next odd number on the numerator, and then it's pi over 4. All right, and then in quadrant 2, the x coordinate is going to be similar to p, but it's going to be the opposite. All right, so you guys try R and S, please. Okay, so check yours with mine. Now, if you weren't here on Friday, you might be a little behind on these angles, so you might want to go back and watch those videos. Okay, and then finally we'll do the pi over 3 angles. All right, so this angle is pi over 3. Then that ordered pair is going to be 1/2 and square root of 3 over 2. So pi over 3 in quadrant 2, what do y'all think? 2 pi over 3. And then the ordered pair, the x is negative, the y is positive. All right, you guys try R and S for me. All right, so underneath here is the unit circle with all the special angles and all of the ordered pairs that correspond to those points. So hopefully soon you're going to be able to create that all on your own. So tomorrow you're going to have a quiz over using the unit circle. And so you're going to have 2 options on your quiz. So I'm going to either give you a sheet that has this much of the unit circle on it. And if you choose to use that one, you'll have to fill in the other things. But it'll just be like you'll get regular credit on your quiz for doing the problems right. Or you can get a totally blank unit circle like what was on this sheet from Friday. And if you choose to use that one, then you can get extra credit on your quiz. So it's up to you. You don't have to decide today. Just before you take the quiz, just tell me which one you want and I'll give you it and it'll be fine.
Okay, so it's like you fill the coordinates.
Everything. So the blank one, you're going to fill in the angle and the coordinates. On this one, you're given a starting point. You still have a lot of angles and coordinates you're going to have to be able to do on your own, either one of them. So why don't you practice it right now? So on this one, this is on the last page of your notes. So figure out these missing angles. So there's 9 missing angles and then 9 ordered pairs that go with them. I think it just to save on room, write the angles inside and then the ordered pairs outside. See what you can do just out of your head. Right now, part of your quiz grade is not going to come from filling this out. So it's just for you to be able to fill it out so you can use it. So the quiz is going to come from answering questions like example 7, A through I or L. So just knowing that on the unit circle, if I'm going to find the sine of an angle, I'm going to use the y coordinate. And if I'm going to find the cosine of an angle, I'm going to use the x coordinate. So on A, they ask us to find the sine of 2 pi over 3. So we're going to go to the angle 2 pi over 3, and then we're just going to give the y coordinate. Right. And then on B, if I want to find the cosine of 5 pi over 4, I go to that angle. Since it's cosine, I'm just going to give the y. All right, so you guys try to do the rest of those on your own. Now, whenever you're doing a whole bunch, sometimes it's easier. You're like, okay, cosine is x. Just do all the cosines and give the x coordinates, and then change your brain over and know that sine is going to give you y. So then do all the sines and give the y coordinate. But it's up to you. You can do it however order you want. Maybe. I don't have them printed yet. Maybe. Do you think you're ready? Are you going to fill it in?
What is it?
All those angles, all those order pairs on the outside, you need to fill those in on your circle, please. Can you see them? Cameron, which unit circle do you want? Blank or the one with some of them on there? Okay. Okay. Let me give you guys these answers real quick, and then I'll give you your worksheets.
So the quiz is just gonna be like this sheet right here.
Yeah.
That sheet.
And we'll practice before. We'll do this activity, and then we'll do the quiz. So.
use the restroom.